Maclaurins theorem is what we are going to cover today. Now, we have seen that you can expand a function using binomial theorem. Now, if you can't use binomial, then you can use Maclaurins theorem, as we are going to say. Now, this is used to expand functions. It states that for a function f of x, then you can expand it in this form. How do we expand it? You get this function, you evaluate it at 0. You get its first derivative, you evaluate it at 0, multiplied with x over 1 factorial, plus you get its second derivative, you evaluate it at 0, times x squared over 2 factorial, you get its third derivative. It depends on the term they want you to stop at, and so on. This shows that there are many other terms coming. Let us try it out using these examples here. The first one is expand 1 plus 2x up to the term with x squared. What happens? What we do, we first let our f of x be this function as we are going to see. So in my solution, you know that now I let my f of x be this function here, 1 plus 2x power a half. Now, I'm up to the term of x squared, so I want this term, up to x squared. So I want the first three terms. So now, I need the first derivative and the second derivative. So can you differentiate this? We are going to use now the chain rule. So now, my f prime of x to be, we lower the power, reduce the power by maintain the bracket, reduce the power by 1, we subtract the higher 1, get negative a half. Then, don't forget to differentiate the bracket. Differentiate the bracket, we get 2. Now, that's what we have. So that this 2 and this 2 will cancel, and so that this will give us our f prime of x as 1 plus 2x power negative a half. Then, I need also the second derivative. So my second derivative, f prime of x, will be, I lower the power, I maintain the bracket, reduce the power by 1, we subtract a negative 1, negative 3 over 2, then we differentiate the bracket, we differentiate this, we get 0, we differentiate to x, we get 2. And so that this will give us negative into 1 plus 2x power negative 3 over 2. Now, we need to evaluate them at 0. So from here, is that my f of 0, when I evaluate this at 0, I'll be having 1 plus 2 into 0 power a half. So I'm going to be having 1 plus 0, which is 1, square root, and anything to power 1 is a 1. When I come to this now, so now this is my f prime of x. So if I evaluate it at 0, I'll be having now 1 plus 2 into 0 power negative a half. So we shall be getting 1 power half, negative half, which will be a 1 also. When I come to this, evaluate it at 0. This is I'm evaluating it at 0. F now prime at 0. So I'm going to put here 0. I'll be having negative 1 subdivided. So now, we put in my formula, which says now my f of x will be f of 0 plus x, f prime of 0 plus x squared, f down prime of 0 over 2 factorial plus other terms coming. So start out just using this formula. So my f of x, which is this, so 1 plus 2x power a half will be, we have seen f of 0 is 1, then plus x times f of 1, then plus x squared, 2 factorial is 2, then f prime of 0 is negative 1 plus other terms. And so that now my 1 plus 2x power half will be 1 plus x, then minus x squared over 2 plus other terms. So that's how you can expand this. Still this, you say in your solution, you let your f of x be natural log 1 minus 3x. I think you know how we differentiate natural log. So my f prime here of x will be, we differentiate this, we get negative 3 divide by this. We differentiate this, then we divide by this. Now, you see for easier differentiation, I'm going to take this up. So this will be now negative 3 into 1 minus 3x power negative 1. Now, to get a second derivative, my f prime of x is going to be lower the power. This times this, I'll be adding 3 now. Maintain the bracket. Reduce the power by 1. Then differentiate the bracket. That's what I'll be having. So now, my f double prime of x, this times this, it's giving me negative 9, 1 minus 3x power negative 2. Then, up x cubed, it means that I also need the third derivative. So now, my f triple prime of x, lower this power, you see this times this, to give us positive 18, maintain the bracket, reduce the power by 1. So subtract here 1, get 3, differentiate the bracket. Differentiate this, we get 0, this one we get negative 3. So if we multiply it there, so our f prime of x, 3 times 18, we get negative 54 into 1 minus 3x power negative 3. Now from here, we evaluate them at 0. So that now my f of 0 will be here. I'll be having now natural log of 1 minus 3 into 0, which will be 0. This will be 0 minus, so we'll be having 1, natural log of 1 is 0. So when I count this f prime of 0, it will give me negative 3 into 1 minus 0 power negative 1, which will give me negative 3. When I count this, my f prime double prime of 0, I'm going to be having negative 9 into 1 minus 0 power negative 2, which will be negative 9. Because any number to power 1 power any number, you get 1. So when I count the third derivative at 0, so it's going to give me negative 54. Now put in my formula, and now my f of x will be, now how we are putting into this formula here. Okay. F of 0 plus x, f double prime of 0, 1 factorial, plus x squared, 2 factorial, f double prime at 0, x cubed of 0, over 3 factorial, plus other terms. So, now our f of x was natural log of 1 minus 3x equaling 2. F of 0 was 0, then plus x, 1 factorial is 1. F prime of 0 is negative 3, then plus x squared, 2 factorial is 2, and then f double prime was negative 9, then plus x cubed. 3 factorial is 6 into, when we evaluate this, we got negative 5, negative 54, plus other terms. Now, set our natural log of 1 minus 3x is going to give us negative 3x. This is going to give us negative 9 over 2 x squared. Now, I think you see here, if I divide here by a 6, I'm going to get a negative 9. So I'm getting negative 9, then x cubed plus other terms are given. So there we have expanded that. So we include this so that because this is an endless series, that's why I always include these 3 dots so that there are other terms coming. Don't ever miss them. Okay, let us see this. The first 3 terms. So in our solution, still we say we let our f of x be natural log of 2 plus 5x. And then differentiate it. Our f prime of x is going to be, to differentiate natural log, we differentiate this, we get 5 over the original function, which will be 5 into now 2 plus 5x. When I take this up, then minus 1. Then now my f double prime of x is going to be, lower this, I have negative 5. When I get this times this, maintain the bracket, reduce the power by 1, Then when you differentiate the back condition is you get 5. Differentiate this, you get 0. So now my f double prime of x, this times this, negative 25 into 2 plus 5x power negative 2. Then start with the evaluate them at 0. So my f of 0 is going to give me, when I put here 0, I remain natural log 2. Then when I put f prime of 0 into this function, so I'm going to be adding 5, 2 power negative 1, which will be 5 over 2 when I push it down. So here, my f double prime of 0, I'm going to be adding negative 25 into 2 power negative 2, which when you push down, you get negative 25 over 4. So that's what we have. Now substituting our formula, our f of x is f at 0, n plus x, f prime of 0, 1 factorial plus x squared of 0 over 2 factorial plus other terms coming. So now, which is natural log of 2 plus 5x, the f of x is going to be f at 0, natural log of 2, then plus my x over 1, 1 factorial is 1, then we see that our f double f prime of 0 is this, then plus x squared, 2 factorial is 2, then negative 25 over 4, then plus other terms, and so now, so that my natural log of 2 plus 5x is going to be now natural log of 2, now plus 5x over 2, then minus 25x squared over 8, then plus other terms. So we have finished this, and hence use the first three terms to evaluate log to base e of 2.05. Now, you know that log to base e of 2.05 is the same as natural log of 2.05, which we can easily write as natural log of. So you can separate this. So 2 plus now 0.05. So when I add this to this, I get back this. Now, if I compare it with what I have, if we compare with the natural log of 2 plus 5x, you see that plus 5x, sorry. Okay, if I compare it with my 5x, this and this, you see this is the same. Means that now from here, my 5x is equal to 0.05. Now my x is 0.01. So now to evaluate it, means I need to put here 0.01. So from my expression, natural of 2 plus 5, now where there is x, for x equal to 0.01 from here. I'm going to be adding now to 0.01 equal to natural log of 2 plus 5 over 2 into 0.01 minus 25 over 8 into 0.01 squared plus other terms. So now we multiply this, we get natural log of 2.05 equal to, now you just press all of this onto a calculator, so 0.01 squared divided by 8 times, then plus 0.05 then plus natural log of 2. Here I'm getting 0.7178. I'm giving this to form decimal places. Remember, our question was log base e of 2.05, which is approximately, this is an approximate value, please. Why? because you see that we are not including all the terms. So that's why I'm converting these to an approximation. Okay, so it's going to be now 0.7178 decimal places, and that is the answer. When you press this on the calculator, I'm sure it's giving you a value close to that. Let me show you mine when I press it on the calculator. I think you can see my value there, and you see it's close to this. So that's it, members. I wish you well.